So question 2 has a part A and a B, and and both of them are pretty much the same process. We're given a function, in this case the function is called f of x, and we're asked to figure out what the output would be if we supplied the function with an input, right? So in the first one for A, we're going to supply an input of 8, and for the other one we're going to supply an input of 7. Negative 7 rather. That's important. It's an important detail. So let's go ahead and look at f of x. The numerator of this function is 6 times the number 8 and then plus 3. The denominator of that function is 2 times, again, 8 is my input, and then minus 3. 6 times 8 is 48. So I'm looking at 6 times 8 is 48, and then I'm looking at 48 plus 3 in the numerator. And on my denominator, I'm looking at 2 times 8 is 16, and 16 minus 3 would be 16 minus 3. 6 times 8, yeah, that's right. 16 minus 3. So let's go ahead and do the 48 plus 3, 48, 49, 50, it's 51. And 16 minus 3 would be positive 13. So the output for this function is 51/13. So over my answer line, no, not 15, 51/13. That's a great answer. 13 itself is prime, so I know there's no common factors here, so we'll just leave the answer as, well, unless 51 is a multiple of 13. It's not. That would be 39, and then 40, 50. No, it's not. I think it's 52. It's a multiple of 13. All right, let's go on to part B. Part B, again, this time we have an input again. Our input this time is negative 7. And really important that we capture this right notationally, right? We have a value of x that is negative 7, and that's getting squared, right? An important distinction here. This says x gets squared, and what is x? X is negative 7. So we are squaring negative 7. That means negative 7 times negative 7. Just so you know, if you just grab one of the TI calculators and you type this into it, this is going to freak you out, because the calculator is going to tell you the answer is negative 49, and it's right. I want you to understand the distinction. What you've typed in is you've said, what is the opposite of 7 squared? You've put this negative 7 and squared it. It's, what is the opposite of 7 squared? That's not what we have here. We have that we want to take the negative 7, we're going to take the number negative 7, and we want to square that. And if you ask your calculator what that is, it will correctly say the answer is 49. So again, we are squaring negative 7, so we're getting a result of 49 from that. And then we've got plus 3 times negative 7. 3 times negative 7 would be negative 21. And then there's the minus 10. So if we look at this, we're dealing with 49, what is it, minus 31. But 9 minus 1 is 8, and 4 minus 3 is 1. So we should be getting an output of 18 when we put negative 7 into that function. So again, over here in my answer spot, I'll write an 18. All right, question 3 is pretty much the other possibility with this. So this question says, please identify the input that would produce the given output. So here's a function f of x, and there's a lot of values that I could put into it, right? The question is, which input would go into this function that's going to produce an output of 42? And you know, if you were to guess for a while, you could put 0 in there, right? If I placed 0 into this function, it would become 4 times negative 5 and then plus 6, which is like negative 20. And negative 20 plus 6 would be negative 14. Well, that's not what we're looking for. We're looking at 42. So rather than sit and guess and guess and guess what this question mark could be, a really good strategy is to just ask it. So say, hey, f of x, by the way, you are 4 times 2x minus 5 plus 6. I want to know what value of x would make you the same as 42. And when I write this equation, right, this allows me to kind of query the function, and I get an answer back, right? I'm gonna simplify this. I guess I'll take away 6 from both sides. So I've got 4 times the quantity of 2x minus 5, and that equals, let's see, 42 minus 6 should be 36. And I'm actually going to divide both sides of this by 4. I'm not going to distribute the 4. I'm just going to divide by 4. That gives me this giant 1 on this side. So I'm looking at 2x minus 5. 2x minus 5 is 36 divided by 4 is 9. We can add 5 to both sides, so I got that 2x is 14, and then I can divide both sides by 7, so that gives me x is, I'm sorry, I'm thinking of the answer. Divide both sides by 2. When I divide both sides of this by 2, I get x on the left hand side, and 7 divided by 2, there's my 7. X is 7. So I believe when I throw 7 into this function, right, when 7 is my input, it produces an output of 42. And I'm just going to quickly double check it, right? 2 times 7 would be 14 minus 5. 14 minus 5 is 9. If I multiply that by 4, I get 36, and 36 plus another 6 is indeed equal to 42. So totally checks. My input is 7, and that produces an output of 42. On this next one, I was really pleased. This actual problem is going to be counted as extra credit. So if you got this one right, it's going to be a plus 2 points. And if you got it wrong, I'm not going to deduct any points from it. But if you look at this, it kind of is a preview of a technique we're going to call looking inside, so that's not very seeable. Let me pick this green highlighter. This thing inside has a value, right? In fact, let me write down what this thing inside is. Whoops. This thing inside the radical symbol is 2x plus the number 12. Now, that thing needs to be something specific if I want to get a square root of 8 kicking out of this machine. And the thing that it is it has to be the number 64, right? Because if you think about this for just a minute, right, when I take the square root of 64, that's when I get a value of 8. So the thing inside has to be 64. Now, you can quickly get that by squaring the 8 and seeing, oh yeah, 8 squared is 64, so that means this thing inside has to be 64. So what I'm going to do is I'm just going to say, hey, 2x plus 12, you need to be the number 64, right? That expression needs to be 64, and then I can say, okay, what value of x makes that true? I solve that by taking away 12 from each side. When I take away 12 from both sides, I get that 2x is 52. 52 is like 50 and 2 more. Half of 50 is 25, and half of 2 is 1. So I'm looking at x, and it must be the number 26. So x is 26 is the solution for part B. 26. And I'm going to put a star by there to remind myself when I'm grading this. This is extra credit. All right, let's move on to 4. Question 4 says, simplify each expression. And all of these, of course, some of the things that we've talked about, when you're simplifying monomials, we're not allowed to leave negative exponents. We can't have any giant ones left behind. We have to gather up all the same factors. We can't have factors spreading around with the same base. All the bases have to be gathered in one location. So if I look at this, I guess the first thing I want to do is take care of the fact that this is being squared, right? So that means this entire 4 times x to the third times y squared needs to be squared. So to square it, right, I could write it out twice. There's 4x cubed y squared times another 4x cubed y squared. Excuse me, 4 times 4 is 16. I've got x cubed times x cubed, that's a total of 6 factors of x. Y squared times y squared, that's yy, and another yy, so that's 4 factors of y, so that's y to the 4th power, which is fabulous. Now I'm multiplying that by something else, so let's bring that in. The first thing I'm going to do is I'm going to look at this 2 to the negative third and just deal with that separately, right? 2 to the negative third, again, if I multiply that by 2 cubed over 2 cubed, this numerator becomes 2 to the 0 power, which equals exactly 1, and my denominator is 8. So this becomes 1/8. So I'm going to say, look, I've got a 1 and then a denominator with an 8. So that's part of that. And then there's an x squared and a y squared. So if I make this look like they're both fractions, right? Across the top, I've got a 16, and then I've got x to the 8th. So let's write down. There's 16, There are 8 factors of x because I've got 6 of the factors of x here and 2 more factors of x. That's a total of 8 factors of x. And then I've got y to the 4th y squared, which is a total of 6 factors of y. So y to the 6th power, and all of that is over 2. Well, 16 divided by 2 is 8, right? So there's a giant 1 there. I could write it out if I want to, but I don't feel like it right now. So I'm just going to go ahead and write down 8, and then it's x to the 8th power and y to the 6th power. Let's look at part B. Part B, let's get rid of these negative. There's this x to the negative 4th. I'm going to multiply both the numerator and denominator by x to the 4th. Again, I can multiply by any number 1 that I want to. This is a convenient one because it gets rid of my negative exponent in the denominator. In my denominator now, I'm left with just 20 times x to the 0 power, and x to the 0 power is 1, so I'm looking at just the number 20. Across the top, I've got 15 and x to the 7th power. So there is another giant 1 in there, right? 15 is 3 times 5, and 20 is 4 times 5. So there is this 1 of 5 over 5. So my answer looks like 3x to the 7th, and all of that is over the number 4. So let's write that down. Whoops, 3x to the 7th, 3x to the 7th power, all divided by the number 4. All right, let's move on to part C. Part C says I've got 3 of these, right? And I guess I'll write it out. I don't feel like writing it out, but I will. I'll write it. It's 5x to the negative 2nd times 5x to the negative 2nd times 5x to the negative 2nd power. So I want to point this out, right? I was cubing the 5, right? I was cubing this whole thing, and look, I get 1, 2, 3 factors of 5. So a shortcut appears to be like, you can just write this as 5 to the 3rd power. And then check this out. I've got 1, 2, 3, 4, 5, 6 factors of x. Actually, it's x to the negative 6, so I should be careful. But look, I had a 3 and a negative 2 right here, so I could have just multiplied those as well. X to the negative 6th power. So I'm going to clear this negative 6, x to the negative 6 business by multiplying by a 1. In the numerator now I just have 5 cubed, and in the denominator I have x to the 6th power. You can leave it like that. 5 cubed is 125, so if you wrote 125 over x to the 6th, that's great. Or I would have taken 5 to the 3rd over x to the 6th also. Okay, last part here is D, and I can see 2 things, right? That I'm gonna do both of these at once. If I multiply this bottom by a to the 1st, b to the 5th, right? I have to mirror that across the numerator, a to the 1st, b to the 5th. I completely destroy the negative exponents that are living in the denominator, right? So that denominator, to be real precise, becomes a to the 0 power times b to the 0 power. But anything to the 0 power is the number 1. So this is 1 times 1, which is 1. Meaning I don't have to write my denominator down, it's just the number 1. But in the numerator, I've got what? I've got a to the 6th power and b to the 10th power. A to the 6th, b to the... Wait a minute. Where in the world did I get a to the 6th power? How is that even possible? That's just like non-thinking, Roberts. So if I look at these again more closely, this is a to the 1st power and this is a to the 1st power. And the last time I checked, if I was to multiply an a times an a, that gives me a squared. So why did I write down a to the 6th? I don't know. But let me quickly change that and write it as a squared. So my answer is a squared times b to the 10th power, a squared times b to the 10th power.